Hello friends, welcome. ನಿಮಗೆಲ್ಲ ಟೆಕ್ talk today. Electric Tech in Karnataka Swagata. As you already know that we have started our preparations for KEA exam of KPTCL 2022, which is to be conducted during 2022 July. And we also know that Karnataka Examination Authority, that is KEA board, will conduct the examination on behalf of KPTCL. So in this context, some of the question papers set by KPTCL, some of the question papers set by KEA for PGCET. No, we need to surely go through this. And this is the fourth video where we are discussing about some of the solutions for previous year PGCET questions. Let us look into the questions, friend. RMS value is given here that f of t is equal to 10 of 1 plus sin omega t. And for the given function, that is f of t is equal to 10 plus 10 sin omega t. Okay, so for this we have to find out what is the RMS value. So as you can just look into the solution, RMS value can be given as square root of these two quantities, okay, which is x square plus 10 by root 2 square. So if we can solve for this, then we can get the answer as 150. Okay, square root of 150 is the answer for this question. That is the option to be marked for given question is option D, which is square root of 150. Next, this question is about transformer. In a transformer, zero voltage regulation at full load. So basically this question is about percentage regulation. Okay, so it has been clearly asked that this regulation will be zero under what circumstances. Okay, now if we have to get the answer for this, we need to have a basic idea about the percentage regulation formula. As you can see, a percentage regulation formula is given as I R cos phi. So actually the formula is plus or minus I x sin phi divided by V2 into 100. So this is the formula to calculate percentage regulation. So whenever this is plus, whenever the symbol is plus, it is the indication that the load is lagging or inductive kind of load. So whenever this is plus, indicates that load is inductive nature. So under such circumstances, the regulation becomes negative. Okay, and towards negative, if we have to negative to positive, then there is one way that whenever the load is leading in nature, the formula to be used is minus. Okay, now you can see here what formula is used. Zero voltage regulation at full load is possible at leading power factor load. Okay, because it's leading power factor load, the formula becomes IR cos phi minus Ix sin phi divided by Vt. Right, so from this formula, we can get to know that zero voltage regulation is possible at leading power factor load. That is option B. Okay, it is not possible during the lagging power factor, and it is also not possible during unity power factor, but it is possible during leading power factor. Okay, next question is the voltage per turn of the primary of transformers that's the voltage per turn of the secondary. Remember friends, here nothing is mentioned that whether the transformer is of step up or whether the transformer is step down. Okay, nothing is mentioned about this, right? So nothing is mentioned whether it is a step up kind of transformer or step down kind of transformer, so that these options are not valid. Even double that of secondary, In order to validate this statement, no much of the information is available in the question. Okay. Now, in that sense, we can mark here that only the option available is option A. We can write down that the voltage per turn of the primary of the transformer is same as the voltage per turn of the secondary. Next is about the synchronous motor. An under-excited synchronous motor behaves as. Remember that whenever we are using synchronous motor in a circuit, we know that synchronous motor has got the field windings. Synchronous motor has got the field windings, for which, of course, we need to give DC excitation. Okay, let us say that F and FF be the field winding terminals of a synchronous motor. Right. Now, the way we excite the field winding determines the behavior of a synchronous motor. That is, whenever it is excited at rated current, whenever the winding is excited at rated current, okay, it behaves as a resistor, so that we can think that it is UPF load, that is unity power factor. So whenever I excite the winding above the rated current, that is called as over excited. So whenever the winding is over excited, it behaves as a capacitor, so that you can think that power factor is leading. Similarly, whenever the winding is excited with the current less than the rated current, it is called as under excitation. Okay, under excitation, it behaves as a inductor. Okay, you need to say that it is lagging power factor. Right. Now, with this explanation, now it becomes very easy for us to mark that under excited synchronous motor behaves as an inductor. Okay. So when number of alternators are connected and they are operating in parallel, the power factor at which each of the alternator operates is determined by. Okay, see here, it does not have any of the relationship with respect to the speed, excitation and driving power, because it has been clearly mentioned that the power factor at which each of the alternators operate. Remember that if I can draw the circuit for this, it is simply about two alternators connected to a bus bar. Okay, there is about two alternators which are connected to a bus bar. Let us say that this is alternator 1, this is alternator 2. Okay, and both of these alternators, they are connected to a bus bar. Let us say that this is connected to R, and let us say that this is also connected to R. Then the second winding is connected to Y, so that this is connected to Y phase. This is also connected to Y phase. Okay, and the last winding is connected to B phase. Let's say it is connected to B. Let's say that this is connected to B, and this is also connected to B. Right. Now, whenever these two alternators are connected, please remember that these alternators, they are connected in parallel, but they also have their own load connected. Okay. They also have their own load connected. Okay. So, of course, the power factor at which the alternators are operating is determined by the power factor of the load. It is because it is not only that the alternators are connected in parallel, but alternator also they have their own loads. In that sense, the power factor at which the alternator operates depends on the power factor of the load. Next question is very simple. A 4-speed squirrel cage induction motor uses how many stator windings? It will use 4 stator windings. So this question is again very simple question. It is about DC shunt motors are used in what kind of applications? So generally they are used at practically constant speed applications. DC shunt motors, they are very popularly used for practically constant speed applications, and you can just make a note of this one that whenever high starting torque is required, we generally use DC series motors. So sheets are used in cables for what purpose? Respective to the solution. Insulation and sheet are the components of a cable that protects the conductor. Okay. So insulation and sheet, whatever we are using, these are the components of the cable that protect the conductor. And the insulation isolates the flow of electricity, and the sheet wraps around the outside of the cable to protect the conductor inside. So sheets are not used for the purpose of insulation. The explanation whatever we have read out, this is not valid. This is not valid. In this notion, this is also not valid because the sheets are used to protect the conductor. Sheet wraps around the outside of the cable to protect the conductors inside. Meaning to say that sheets are generally used to protect the conductors. In that sense, it is option B. Sheets provide mechanical strength. Right. For stability and economic reasons, we operate the transmission line with power angle in the range. So this question is about power angle. Okay, as you know that this power angle is generally measured between E and V of an alternator. Remember that E is the EMF induced in alternator winding, whereas V is the terminal voltage. Okay. Now, the angle between these two is called as power angle. So this is also called as load angle or torque angle. Right. So it is also called as load angle, torque angle, or power angle. So it is denoted by delta, and for stable operation, its range is actually between 0 to 90 degrees. Okay, this is the standard way power angle curve looks like. But this is the ideal equation. In practical cases, the normal values of delta lies in the range of 0 to 30 degrees, and for economic reasons and for stability reasons, we operate transmission line with the power angle range of 30 to 45 degrees. Next is a voltage controlled bus is treated as a load bus in subsequent iteration when. Okay, so this is about this question is with respect to the load flow studies. So during load flow studies, we know that there are different methods like the Gauss-Seidel method, Newton-Raphson method, then decoupled method, then fast decoupled load flow method, and so on. Right, so whenever we are doing the load flow analysis, voltage controlled bus. Okay, what is meaning of voltage controlled bus? You can just go through the basic classification of electrical power system buses over here. One is called as PV bus or generator bus. Specified quantities are P and V, and unknown quantities are Q and delta. It is called as generator bus or PV bus. PV bus means P and V are specified, Q and delta are not specified. Remember that in any load flow solution, the study whatever we do is related with P, Q, V, delta. Okay, so these are the 4 parameters always be considering load flow. So out of these 4 parameters, in any kind of buses, you can say 2 will be available and 2 of the parameters we have to do. Okay, next classification, as you can see here, is load bus. The next classification is load bus, or also called as PQ bus, so that P and Q are available. So if P and Q are available, then we have to calculate V and delta, as you can see. Similarly, slack bus. So slack bus is the concept that we always say that voltage is 1 and angle is 0 degrees. Okay, V at an angle delta degrees, whereas this fixed value we consider. Since we are considering the values of V and delta, of course P and Q we are getting. Okay. Now this voltage controlled bus is nothing but the generator bus of PV bus. Okay. Now it has been given over that PV bus is considered as PQ bus in which case? That is what is asked here. Okay. A voltage controlled bus is treated as load bus in subsequent iteration when the reactive power limit is violated. So whenever this reactive power limit is violated under such circumstances, since we have to balance for the reactive power, we cannot consider it as a conventional PV bus. Okay, since we have to compensate for the reactive power limit violation, we have to consider PV as equal so that we can compensate them. So for the violation of reactive power limit, that PV bus is treated as PQ bus. That's what we have discussed now. And if the Q is beyond the limit of Q max or less than the limit of Q min, then choose the latest value. So this is about the procedure, whatever we follow in load flow studies, given that whenever your Q minimum, so whatever the value we obtain, so whether it lies in this range of between Q minimum and Q maximum, that we have to check it. Anyhow, the answer expected for this question is whenever reactive power limit is violated, that is option C. Thank you friends, we shall continue our discussion in next part of our video series. Thank you all.